Okay, PCAM, I'm pretty sure I figured out my phone issues from earlier, so now we're going to have some nice horizontally filmed videos. Let's look at 6.105. This problem cracks me up for several reasons. In lots of other places in the book, they're really careful with their sig figs and make sure to give you exactly 3 or exactly 4. And this one's funny because if you look at the 200 ml of coffee, that's 1 sig fig, or the microwave power of 900 watts, that's 1 sig fig. Anyway, let's solve the problem. So it wants to know how many photons will be required to heat 200 milliliters of coffee from 23 degrees Celsius to 60 degrees Celsius. So the first part is we got to figure out how much energy is going to be needed to do that. And that is a fairly standard thermochemistry problem. So let's come on over here. And we can see that the heat needed, we're going to use the MCAT equation. Q equals MC delta T. Water, we're assuming the coffee has the same density of water. That's 200 grams of water. Times the heat capacity, times the change in temperature, and that brings us to a total, if you just multiply it, of 30,932 joules. Okay, so that's how much energy we need to do it. But the question is, how many photons are needed? So now we got to figure out how much energy is in each photon. So that's part 2 here. So we are going to use E equals h nu, which is equal to hc over lambda. There's Planck's constant for you, the speed of light, and then we're told that they are 11.2 centimeter photons, so that's 0.112 meters. Multiply that out, and you get that many joules per photon. So finally, put it all together, 30,932 joules are needed, 1.77 joules per photon. If you're paying attention to our units, you'll see that we need to do some division. The joules will cancel. I'll go ahead and do that right now. Joules cancel, and we are left with 1.75 times 10 to the 20th photons. I regret asking you to do part B for several reasons, but they actually make a mistake. It tells you that a watt is a joule second. It's actually a joule per second. So it's kind of embarrassing for the textbook to have this mistake, especially when it's the 13th edition. But coming back on over here, 30,932 joules of energy will be needed. 900 watts means every second 900 joules of energy can go in. So a little division right there shows us that 34.4 seconds.